So now we will be discussing about inverse relation, right? Inverse relation and complement relation. So what does inverse relation and complement relation mean, right? So basically, if I have a relation which is A comma B, right, such that A is less than B, right, then my inverse relation will be, I will flip my A comma B, right, I will flip the relations, so it will be B comma A and this will be written as B, right, B greater than A. This is how I will write my inverse relation. And suppose the same thing I want to write, right, this is my R, A comma B, and A is less than B, then R complement will be A comma B, right, but A greater than or equal to B, but not less than B, right. So this is the complement and this is inverse. It means flip every pair AB to B comma A, and for complement all pairs but not in R, right. Now suppose I have R is equal to A comma B such that A divides B on positive integer, right. So my R inverse will be thus B comma A and A divides B, right, and the same R complement A comma B, but A does not divide B, right. Now properties of inverse relation. So first property is, if a relation R and relation S, I have to take intersection, it will be relation R inverse and inverse relation S and intersection between them. Similarly, relation R union relation S inverse, I will write it as relation R inverse union relation S inverse, and suppose I have S dot R, that means S and R composed, it will give me R inverse composed with S inverse, right. Now representation of relations using matrix, right. Suppose A relation R from set A to B is written as like A1, A2, AM to B1, B2, Bn, written as 0, 1 manner in matrix, right. M R will be given as M I comma J, right, where M I J is equal to 1 if AI Bj belongs to R, right, or AI is related to Bj. Otherwise Mij will be 0 if AI Bj does not belongs to R or AI is not related to Bj, right. So now I can write this as, suppose I have relation A is equal to 1, 2, 3, I have set A and B as 1, 2, right, and R contains A comma B such that A is greater than B. So I will have relation R as A greater than B, so it will be 2, 1 I can have, then I can have 3, 1 and I can have 3, 2. So my matrix will be like this, right. This is 1, 1. So 1 comma 1 will be 0, 1 comma 2 will be 0, 2 comma 1 will be 1, 3 comma 1 will be 1, 3 comma 2 will be 1, and this is also 0. This will be my matrix, right? Now, what does join and meet means? Join means or, meet means and just like we add or subtract two matrices, we can join or meet two matrices, right? So suppose I have to join A matrix, I have to join set A with set B, right? So I will write A or B element wise or, and this will be 1 or 1, it will give 1. This thing you know, if this was A meet B, then 1 and 1 will give me 1 also. If it was 0 here, so it will give me 0. It was 0 here, it will give me 1, right? Now, suppose I want a Boolean product, right? I am erasing this and now suppose I want Boolean product, right? That is denoted by A dot a big circle and then B, right? And suppose A matrix is M cross K, B matrix is K cross N, and A Boolean product with B, right, is given by Cij, which will be equal to AI1 meet B1j or joined by AI2 meet B2j joined by up to AIK meet BKJ, right? This is all about Boolean product of two matrices, right? Basically, what you have to do, you have to replace multiplication with and plus with or. This is the trick. You can remember for it, right? Now, we will discuss about closures, right? So let me erase this also. There are three types of closure, right? First is reflexive closure, second is symmetric closure, and third is transitive closure. So let me discuss one by one. In reflexive closure, every element must be related to itself, right? So reflexive closure will be R union triangle, where triangle is A comma A, where A belongs to set A. So I will just add all A comma A pairs that are missing. Suppose R is my A comma B such that A is less than B on integers. So R reflexive will be A comma B such that A is less than equal to B, because I will take union of A comma B, A less than B, union A comma A belongs to Z, right? Now symmetric is, if A comma B is in R, then B comma A must also be in R. So symmetric closure is basically R union R inverse, where R inverse is B comma A such that A comma B belongs to R. Right. So I have suppose R A comma B such that A is greater than B, then R union R inverse will give me A comma B such that A does not equal to B, because I will take all cases also of B comma A greater than B, right? And when I will perform union, so I will get this thing. And talking about transitive, so suppose if A comma B are there and B comma C are also there, so A comma C must be present in R. So it will be given as R transitive, R union, R composed with R one time, R composed with R square, union R composed with R to the power n minus 1. If n is number of elements in set A, right? So suppose I take an example. I have R as 1, 2, 2, 3, 3, 3. So R composed with R will give me, that is R square will give me, right, 1, 2 and 2, 3 is there. So I will have 1, 3 and then 2, 3, 3, 3. So 2, 3 and then I will have, yes, 3, 3, 3, 3, 3, 3, right. Again I will find for R cube the same thing I will write, you can calculate. So this is the same thing. Now R transitive will be the union, so it will be given as 1, 2, this and this all, 1, 3, 2, 3, 3, 3. Now I have this again R and I want reflexive closure, right? So I will add all AA pairs, right? So 1, 1 and 2, 2 will also be added to my R for symmetric, and for reflexive, sorry, this was for reflexive, sorry, for symmetric, what I will do, I will also provide 2, 1, right? I will also provide 3, 2 for this, right? So this is all closures explained, right? So this is all for today.